Okay, let's unpack this. We're kicking off a deep dive today, really getting into the foundation of India. It's a geological story, millions of years in the making. We've got this stack of research here. It's like a high-def map showing the huge physical forces that built this land. A landmass so diverse it has, well, practically everything. Our goal isn't just listing features. We want to understand the why. We're talking mountains, plains, deserts, plateaus, islands, the whole set. That's Q1 really setting the scene for the sheer variety.
It really is an epic story. Collision, massive upheaval, and then eventually stability in places. To get why Indian life is the way it is, agriculture, industry, where we have to start deep, way below the crust. We're tracing movements millions of years old.
Right.
And what's truly fascinating is how these massive slow-motion earth mechanics, this constant shifting of plates, it's like the source code. It defines everything. Where the best soil is, where the mineral wealth is buried, it's all written in the rocks.
Okay, that sets us up for the science bit. Plate tectonics. The Earth's crust broken into these massive chunks kind of floating. Our sources say 7 major plates globally. It seems like a small number, but they dictate so much, don't they?
Exactly. And how these plates interact at their boundaries is crucial for India's story. When plates pull apart, move away from each other, that's a divergent boundary, sometimes called constructive, because new crust often forms there.
But India's story isn't really about plates moving apart, is it? It's the opposite, the coming together.
It's the ultimate convergence story, yes. When two plates come together, crashing, crumpling, one sliding under the other, what we call subduction, that's a convergent boundary, also called destructive.
Destructive. But it builds things.
Paradoxically, yes. This immense destructive pressure is actually what builds the highest mountains on the planet.
Okay, quick flashback needed here. Before the big crash, we need to picture the old supercontinent, Gondwana land. Huge piece of land. But our sources point out something specific, North America, not part of that setup.
That's important context. It sets the stage for the main event. The Indo-Australian plate, starting its long journey north, imagine this massive piece of crust just drifting relentlessly.
For millions of years.
For millions of years. Then, around 50 million years ago, it collides with the much larger, more stationary Eurasian plate.
Like a continental scale collision. Incredibly slow motion, but with unimaginable force. And that impact, that convergence, it didn't just make hills. It directly created the Himalayas, the highest mountains on Earth.
Absolutely. And here's a key contrast you need to grasp. The Himalayas are geologically young, dynamic, still rising in places, but the southern part, that triangular bit, the peninsular plateau, that's one of the most ancient, stable land blocks on the planet.
Wow, okay. So young and active in the north, ancient and stable in the south.
That juxtaposition really defines India's geography.
It's incredible. The energy involved must have been immense. Let's focus on those giants now, the Himalayas.
Yeah.
Defining the whole northern border, right? Sweeping from the Indus River across to the Brahmaputra, running west-east.
Yes, and we can break them down. Think of layers moving south. First, the highest ones. The Great or Inner Himalayas, the Himadri, these are the real showstoppers. Peaks averaging, 6,000 meters high, just immense.
6,000 meters average height. And what are they made of? The core tells a story, doesn't it? Not just scraped up sediment.
Exactly. The core is primarily granite. Dense, forged by heat and pressure. That tells you about the intensity. The crust got pushed down so deep, it essentially melted and recrystallized under that unimaginable pressure.
That makes sense.
And a specific point to bring the scale home. We always talk about Everest, but Kanchenjunga, standing at 8,598 meters, that peak is specifically within India's territory.
Kanchenjunga, right. Okay, moving south from the Himadri.
We get to the Himachal, or Lesser Himalaya. Still very rugged, just not quite as high. This is where you find ranges like the Pir Panjal, the Daladar, the Mahabharat ranges. Very prominent features.
And then the outermost edge, the Shivaliks. But what about the space between these ranges? There are valleys, right?
Yes, the duns. Between the Lesser Himalaya and the Shivaliks, you find these longitudinal valleys.
Duns, like Dehradun.
Exactly like Dehradun, that's the most famous example. They're basically these relatively flat-bottomed valleys filled with sediment washed down from the mountains. They became important areas for settlement, for travel, economically significant.
Interesting. And we also carve up the Himalayas regionally. I remember reading about the Kuman Himalayas.
Yes, that's a specific section. The part lying between the Satluj and Kali rivers is known as the Kuman Himalayas. Just a way to divide that huge arc.
And the mountain building doesn't just stop there, does it? It curves around.
It swings south and east into the Purvanchal, the eastern hills, ranges like the Patkai Hills. These form that distinct border with Myanmar. It's more evidence that the whole collision process is still shaping the land far from the main range.
Okay, quite a journey through the mountains. Now let's make a big descent. From those dynamic peaks down to, well, their consequence really, the heartland, the northern plains, often called the granaries of the country, and for good reason, right? This is where early civilizations could really take root. That fertile base was crucial.
Absolutely crucial. Their formation is relatively simple but vital. They're formed by sediment deposited by three major river systems, the Indus, the Ganga, the Brahmaputra. So they're primarily made of alluvial deposits.
Meaning incredibly rich soil.
Very rich, finely ground soil. But there are nuances. The western part, drained by the Indus and its tributaries, that's the Punjab Plains. But look closer at the soil itself. The older alluvial soil, usually found a bit higher up, above the active floodplains, it contains these hard, limey nodules called kankar. This older soil type is called bangar.
Bangar. Okay, so that's key for farming, isn't it? The Bangar lands. They're older, higher, maybe less fertile than the newer flood deposits the Kut are, because of this kankar.
Generally, yes. The kankar can make deep plowing difficult, so it's soil science, directly impacting agricultural success for centuries.
Right. And the power of these rivers. You mentioned the Brahmaputra. There's that amazing fact about the island.
Oh, yes, Majuli. The sheer amount of sediment carried by the Brahmaputra has built the world's largest inhabited riverine island, Majuli, right in the middle of the river. It's a mind-boggling example of these geological forces still actively shaping the landscape.
An entire inhabited island built by the river. Is it stable, though, or constantly changing?
Oh, it's constantly changing. Erosion on one side, deposition on the other. That dynamism is a huge challenge for the people living there. It just shows that even the stable plains are subject to these massive river forces.
But now let's pivot. Let's go back to that other extreme we mentioned, the ancient stable core, the peninsular plateau.
Ah, yes, the mineral vault.
Yeah.
This is where India's industrial strength comes from historically, the storehouse of minerals, critical for industrialization. Precisely. Unlike the young, folded Himalayas, this ancient block has been stable for hundreds of millions of years. Plenty of time for valuable mineral deposits to form and concentrate. Structurally, its northern boundary is often marked by the Narmada River.
Okay, the Narmada. And this plateau isn't uniform, is it? It has regions.
No, it's vast. The eastward extensions of the bit we call the Central Highlands, for example, are known locally as Bundelkhand and Bagalkhand. These areas are part of that ancient shield holding significant resources.
And the soil here is completely different again, not alluvial like the plains. You mentioned the Deccan Trap area, famous black soil, that's volcanic in origin, right?
Entirely volcanic. Huge flows of lava millions of years ago solidified into basalt rock.
So if it's volcanic, but you describe the plateau as ancient and stable, does it mean the volcanoes are long dead?
Oh yes, the activity is a long dormant, but the legacy is the rock. That basalt weathers down into this incredibly rich, dark, moisture-retentive black soil. Perfect for cotton, which is why that region is famous for it. A direct link from ancient eruptions to modern agriculture.
Amazing. And the edges of this plateau, they have mountains too, the Ghats.
They do. The edges are marked by the Western Ghats and Eastern Ghats. The Western Ghats are quite high, quite continuous. Average elevation may be 900 to 1,600 meters. They create a significant rain shadow effect.
And the Eastern Ghats are different. Lower?
Yes, generally lower, and they're broken up by the large rivers flowing out to the Bay of Bengal. Their highest peak is Mahendragiri, about 15,501 meters, noticeably lower than the highest peaks of the Western Ghats. This difference really shapes the climate on either side.
Okay. Before we hit the actual sea, there's that dry bit on the western edge, the Indian desert. Very arid.
Extremely arid, so much so that the only significant river there, the Luni, often only flows properly during the monsoon, and even then it frequently just disappears into the sand due to evaporation and seepage before reaching the sea.
The Luni, a perfect symbol of that arid environment.
It really is. Okay, now let's make that final transition to the coasts and the islands.
All right, the sea boundaries. The coastline has distinct names, doesn't it? On the west coast, the northern part, say Mumbai down to Goa.
That's traditionally known as the Konkan Coast, a very important stretch historically for trade.
And south of Goa, down through Kerala.
That section of the western coastal strip is the Malabar Coast. Equally famous, different character. These coastal strips are vital ports, fishing, unique cultures.
And jumping over to the eastern coast, there's a huge lake there.
Chilika Lake in Odisha. It's the largest saltwater lake in India, A massive lagoon, really important ecologically, a major feature.
Okay, coastlines covered. Finally, the islands, those scattered gems. Let's start west in the Arabian Sea. Lakshadweep, what's their story?
Lakshadweep is fascinating because the entire group is made of small coral islands, built by tiny marine organisms over time.
So, completely different geology from the mainland mountains. Biological origin.
Entirely different, relatively young, quite fragile ecosystems. The group was officially named Lakshadweep back in 1973, and its administrative center is Kavarati.
Coral Islands. Okay, now swing east, Bay of Bengal, the Andaman and Nicobar Islands. Not coral, these ones.
No, these have a much more dramatic tectonic origin. They're essentially submerged mountain peaks, part of that same larger arc related to the Himalayan collision, and they hold a unique distinction. India's only active volcano is located here.
An active volcano. So that reminds us the geology is still alive there.
Absolutely. It's a constant reminder that even though the main Himalayan collision is far away, the underlying plate tectonics, the subduction processes, are still very much active, shaping these islands, causing earthquakes, and powering that volcano. It's a dynamic zone.
Wow. We've really covered the whole map, haven't we? From those 6,000-meter granite peaks of the Himadri, down through the fertile plains with their Bangar soil, across the ancient volcanic Deccan Trap, and out to the coral specks of Lakshadweep and the volcanic Andamans.
It shows, doesn't it, how every single feature, why the peninsular plateau is full of minerals, why the Konkan coast exists, where it does, it all traces back to those massive geological forces we talked about at the start. It's not random. There's a deep logic to India's geography. It's a story told over millions of years.
A meticulously constructed story.
Exactly. And the takeaway for you listening is the application. Understanding the stability of the peninsular plateau explains why it's the mineral storehouse. Understanding the young, dynamic rivers explains why the northern plains are so fertile, why they feed millions. It's cause and effect, written right there in the landscape.
So a final thought to leave everyone with, connecting back to the very beginning. We know the Indo-Australian plate is still moving, still pushing north, however slowly. What might the next chapter look like, maybe thousands or millions of years from now? Will the Himalayas get even higher? Will new faults appear? Something to perhaps explore on your own.